There is a question from continuity chapter. This question uses the concept from sandwich theorem. So let us read the question. Let f from R to R be defined as f of x equal to limit. That function is given where x not equal to pi by 2 and 1 when x equal to pi by 2. So when x is not pi by 2, what is our f of x? F of x is limit n tends to infinity. You can see that step x is common here. So I am taking step x outside. So it will be 1 by 1 plus n square, 3 by 2 plus n square plus 5 by 3 plus n square plus etc. plus 2n minus 1 by n plus n square. Now outside I have written greatest x. So when x not equal to pi by 2, this is our f of x. Now what we are going to do is, we are going to find this limit. This limit part we are going to find. So what is this limit? Limit n tends to infinity 1 by 1 plus n square plus 3 by 2 plus n square plus 5 by 3 plus n square plus etc. 2n minus 1 by n plus n square. This limit we need to find. Okay. For this we are going to use sandwich theorem. Okay. So for the time being, the question is reduced to this part. Which part? Finding the limit of this particular expression. For this, we know that denominator is common. Then if all the denominators are common, are same, then we can take a common denominator. But the denominators are different. So what we are going to do is, this expression we took 1 by 1 plus n square, 3 by 2 plus n square, 5 by 3 plus n square, etc. 2n minus 1 by n plus n square. So what I am going to do is, I am taking an expression in which all the denominators are same, and I am taking the denominators as 1 plus n square. Okay. So my expression is like this. I took 1 by 1 plus n square, 3 by n plus n. Okay, 1 second. 1 by n plus n square I took, then 3 by n plus n square I took, 5 by n plus n square I took, and last 2n minus 1 by n plus n square. That is, all the denominators are taken as this last denominator. Okay. Now you tell me, this one or this expression, which is larger? This particular expression or this expression, which is larger? All the numerators are same, and the denominator is more here. If the denominator is more, then what will happen? This expression will be larger than this expression. So what I can say, this is less than 1 by 1 plus n square, 3 by 2 plus n square, 5 by 3 plus n square plus etc. plus 2n minus 1 by n plus n square. I hope it's clear. What I did, we have an expression in which the denominators are different. What I did, I considered an expression in which all the denominators are same. Okay. And it is clear that here denominator is more than denominators of this expression. So the left part, this expression will be smaller than this one. Okay. So that we understood. Now what I am going to do is, I am going to consider an expression where denominator, all the denominators are 1 plus n square. This one 1 plus n square. Okay. plus then 3 by 1 plus n square plus 5 by 1 plus n square plus etc. plus 2n minus 1 by 1 plus n square. Now this expression will be larger than our required expression. Why? Because this expression's denominators are smaller than the denominators of our required expression. Okay, so I hope you understood this inequality. This one, this is the inequality. Okay, so this expression is less than our question, less than the other one. Okay, now what I need to do, I need to use sandwich theorem. What is sandwich theorem? Let me write on the top. Sandwich theorem states that f of x less than g of x less than h of x in the neighborhood of a, and limit extends to a f of x and limit extends to a h of x are same, then whatever its value, let it be L, then that will be the limit of g of x at a. That is sandwich theorem. So let me find the limit of this function. Which function? This one, left function, 1 plus 3 plus 5 plus etc. plus 2n minus 1 by n plus n square. What is this? Numerator is a series, so n tends to infinity. Numerator is sum of the first n odd natural numbers. It will be n square, so it will be 1. Okay, so I got the limit of this function. This function I got. Okay, now let me find the limit of this function. What it will be? Limit n tends to infinity, 1 plus 3 plus 5 plus etc. plus 2n minus 1 by 1 plus n square, which will be limit n tends to infinity, again n square divided by n square divided by 1 plus n square. What is this? This is also 1. Why these two functions so this expression have limit is 1? Because if you have limit at infinity and numerator is a polynomial and denominator is a polynomial of the same degree, then limit is equal to ratio of their leading coefficient. What is the degree of numerator? 2. What is the degree of denominator? 2. So what is the answer? Coefficient of n square, which is 1, divided by coefficient of n square, which is again 1. 1 by 1, 1. Here also same result. Okay, so we got this. So we got the limit of f of x, which is 1, limit of h of x, that is also 1. So limit of g of x will be 1. So what is our limit? N tends to infinity, 1 by 1 plus n square plus 3 by 2 plus n square plus etc. 2n minus 1 by n plus n square, which is 1. Okay, so what is this limit? What is this limit? This limit is 1. So what is your function in this case? 1. Okay, so now I can rewrite this function. Okay, so what will be my function here? My function is f of x. When x not equal to pi by 2, it is this into step x, this one into step x. So what it will be? Just step x. Okay, so that I got. Now when x equal to pi by 2, what is it? 1. So this is my function. Now you tell me, when x is pi by 2, what is f of x? 1. So I can write this entire function as simply step x. Because when x is pi by 2, f of pi by 2, what is f of pi by 2? F of pi by 2 will be step pi by 2. What is step pi by 2? 1. This is what we have here. So instead of writing this, I can simply write f of x as step x. Now look at the options. This is our final function. F from R to R, f of x is step x. Is it injective? No. Why? F of 1 is step 1, which is 1. F of 1.1 is also 1. F of 1.2 is also 1. So this is not a injective function. Injective means 1 function. It is not 1 function. So option A is wrong. Now, it is not differentiable at pi by 2, which is wrong. Why? Step x is differentiable at all points except integers. So pi by 2 is not an integer. So at pi by 2 it is differentiable. So option B is correct. Now option C. F is discontinuous at all integers, which is correct, and continuous at pi by 2, which is also correct. Now option D. F of x is an unbounded function. Yes. Why? Unbounded function means its range, bounded function means its range lies between two finite values. Here what is range? Range is z. It is not lying between finite values. Okay. So it is unbounded function. So this is also correct. Now what is the question? Question is, which of the following are correct? So option C is correct, and option D is also correct. So that's the answer. Okay. Thank you.